Okay. Yesterday we learned about local or relative max and min. Yes? And what we learned, recall, what we learned, there were two important things to learn about the local max and min. One is that local max at C means f at C is bigger than or equal to f at x for all x's near C. Yes? And the local mean or relative mean, we defined it the same way with the other way around inequality. And then we learned about one fact, which was called Fermat's theorem, which says, basically, I can now rewrite it. Yesterday we had, Monday we had a version of it. Now I can rewrite it in a different way. If f has a local max or min at C, then C is a critical point for f. And by critical point, this was just definition. We had this mathematical fact, and we are getting this definition from that mathematical fact. Critical point means that either f is not differentiable at C, or f is differentiable and the derivative is equal to 0. So that's the meaning of critical point, and that was the Fermat's theorem. Today, we are going to study another type of max and min. It is called absolute. So definition. Let f be defined on a domain D. So we have a fixed domain. It could be the domain of the function, or it could be someone gave you this interval set, work with this interval, with that function on this interval. F has an absolute max value at C if f at C is bigger than or equal to f at x. This is very important, that when we were doing local, we said that f at C is only bigger than f at x when x is close to C. When you're talking about absolute max, this x must be for all x's in that domain. This could be the function's domain. This could be an interval that I fixed from the beginning in the problem. See, I am using two different terminology here. I just want to make sure that you remember those two. I say either local or relative. These are the same words. They have same meaning for us. Or here, in the case of absolute, you will hear me sometimes saying global. Global max min, absolute max min, they're the same thing. Local max min, relative max min, they're the same thing. Yeah? Yes, please.
When you say for all x near C, what kind of a range are we talking about for x? 100,000, 10,000, 500?
That's a very good question. I am going a little bit vague here, but what I mean is that if you get very close to C, so in other words, you fix an interval where this happens around C, that's enough for me. So I am not talking about a specific range. I'm saying that there is a neighborhood of X where this happens. And this neighborhood could be a range of 1,000 of unit or range of 0.001 of the unit. Yeah? You just need to find one neighborhood around C that happens. Done. Okay? Any other questions? Any other comments? Okay. And local mean, you can define the same thing. I want you now work with your friend and try to come up with examples of functions which have local max. Sorry, forget local. I'm talking about global. Global max or absolute max on their interval, but not global or absolute mean in their interval. So find examples of functions where functions f, where case 1, f has a global or absolute max, not absolute min. Flip that. Another example which has a global min, not global max. And another function f that has no global max nor global min. 3 different functions. I want you to work with your friend, and we are restricting ourselves to the domain of the function, the whole function. Come up with 3 examples. You try to answer that question, or you have a question? Yes.
Functions approaching infinity or negative infinity of minimum.
See, when we are talking about absolute max and min, I'm talking only the values of function at a real number, a real point. Infinity is not a value that I can plug into my function. This is not about limit. This is about the value of the function. So maybe we should think a little bit more about your question when it comes how you find the relation between local absolute max and min and infinity. But to start with, it's not clear infinity should have anything to do with the local max and min or absolute max and min. Okay, make sense? Yeah? Okay, I'll give you 45 seconds. You, your friend, you're trying to come up with examples of those 3. Has global max, not global min, not global max, neither of them. I'll give you 45 seconds. You work with your friend. Make sure that you have all those examples there. And 45 seconds starts now. Go ahead, please. Okay, what is the example of function which has global max but not global mean? Yes, please. F of x or maybe negative f of x squared, yes? This one on the whole real line has the highest value, which is 0. That's global max value. And it doesn't have any global min value. What about the other way around? Other way around. F of x equal to x squared, yes? How about no global max, no global min? Yes, please. Pardon? A linear function, or just let's make it simple, f of x equal to x, yes? Now, I want you to see this specific example. These are the examples on the whole domain. But I can play with this thing a little bit more. For example, f of x squared on the interval, say, -1, -2 to -1. Let's look at this function on this interval. When I draw this function on that interval, how does this look like? Okay, so remember this is our parabola friend. And then from -2, so this is the part we are considering all the way to -1. Does function f of x equal to x squared have absolute max in that interval? Yes, absolute max. Because when I look at this, f at -2 has the highest value. So this is absolute max value. Yes, it is not our point of the favorite point, or it is not anymore the whole real line. By restricting our function on this domain, yes, we could have absolute max. How about absolute min? Does this function have absolute min on that interval? I want to see this. How many of you believe that function f of x equal to x squared has absolute mean value on the interval -2 close to -1 open? How many of you believe it has? Don't worry, just, okay, I want to see some hands up, okay? How many of you say no, there is no absolute mean value on that interval? How about the rest? Okay, I won't ask that question anymore. This is, see, when we get closer to the end of that interval, the values get smaller and smaller. And the smallest value that we could get here, if it was included, would be f at -1. But since we have not included that one, so it means that the smallest value we took away. We can get as close as we want to that value, but we never can have that value. This example shows that when you're talking about absolute max and min, the domain plays very important role. And as you can see, in general, there is no guarantee that function will have absolute max or absolute min. However, there is one theorem that makes us sure that there will be absolute max and min if, so this is the theorem, f has absolute max and min value. I did write it very bad. So let me write, sorry, I need to rewrite that. Every continuous function on a closed interval has absolute max and min values. So the function, if your function is closed, if your function is continuous, and the interval you're working on is a closed interval. Closed interval means that both sides must be closed. Then your function definitely will have absolute max and absolute min on that interval. We will take this as, okay, I'm sure that the functions with those two properties will have absolute max and min. Now we want to learn how do we find it. And that's the next thing we will do, and then we will do some examples. Any questions, any comments before we move on? Okay, then how to find absolute max min values of a continuous function on an interval A. I'm writing it in step form, but what I want you to understand is this. Absolute max and min can either happen in critical points, at critical points, or at the end points of the interval. So we will go find all critical points of f on the given interval. It may have other critical points. I'm going to throw them all out if they are not in that interval, and evaluate f at those points. First, we have to check critical points. So we find all the critical points of the function, but consider only the ones that are in the given interval, and evaluate our function at those points. Step 2, evaluate f at end points. Well, means what? Means f at A and f at B. Okay? Now, I have a bunch of critical points inside that interval. Say there are 5 of them. I evaluated function at those 5 points. I evaluated function at the end points. Together, I have 7 points. Highest value of those 7 points is the absolute max. Lowest one is the absolute min. That's simple. The last step, highest values of f found in steps 1 and 2 is absolute max value. The lowest value of f found in steps 1 and 2 is absolute min value for the function on that interval. So, yes, please. So, yeah, okay, so that is, so the question is that when you look at sine x, and we have highest value is 1, the lowest value is -1. So which one of those ones we take as absolute max? When you're talking about absolute max value, it doesn't matter where it is happening. What matters is that what is the value which is highest. In the case of sine, it is 1. Absolute max value is 1. Happens at what points? At pi over 2, 2 pi plus pi over 2, 2 pi, 4 pi plus pi over 2, and so on. And the minimum value, absolute mean value is -1. Doesn't matter where it is happening, but absolute min value is -1. Absolute max value is 1. Make sense? Yeah? Okay, let me write an example. We start that example and then we see how many more we can do. Find absolute max and min values of the given functions on the given intervals. The first function is f of x is 2x cubed minus 3x squared minus 36x plus 20 on what interval? On the interval 0 to 4. Well, I'll give you 1 minute, and my hope is that in that 1 minute, you will be able to find the critical points of this function and at least evaluate the function at those critical points. Yes, please.
3bx or 36x?
It is 36x. Thank you. Okay, 1 minute starts now. You have to now start finding the critical points first, and then we will do more examples. This is a polynomial, so it is differentiable everywhere. Means that the only critical points we can have are the ones that the derivative is equal to 0. So let's find the derivative, which is 6x squared minus 6x minus 36, set it equal to 0. Yes? Okay, I want to solve this. If I factor out 6, here would be x squared minus x minus 6. We did this example yesterday, on Monday, I believe. So here we get x minus 3, x plus 2 is equal to 0. That means that x either is 3 or x is negative 2. We have two critical points, but only one of them is in that interval. So I don't need to consider negative 2 because is not in the given interval 0, 4. So I threw that one out. I only care about the critical points in the given closed interval. Now, f at 3. What is f at 3? Oh my God, this is a, okay. 54 minus 27, that's 27. 47 minus, it's a huge negative number, yes? Sorry, what was it? 108. Negative 108.
For 36 times.
Oh, this is 108, I see. 108 minus 40, or negative 108 plus 47, which gives me negative 61, yeah? Yeah, did anyone get 61? I'm the only one getting 61. 60. Let me see, how many of you got negative 61? Oh, I have enough. I believe you now. I can check my notes. My notes says negative 67. Did anyone get negative 67?
Calculator.
Use it, but don't tell anyone. Okay, use it. Okay, so that's one point that we have to have. The other 2 points are the end points, f at 0, f at 4. F at 0 is 20. F at 4, maybe that was
61.
and f at 4 is negative 44? Yes? I heard one yes, so I take it. So, critical points, end points. This is one when you're trying to find absolute max and min. In other words, now I can ignore every other point and just focus on these 3 values. This one, this one, this one. And then we want to find which one is the smallest one. Okay, this is the smallest one. So this is absolute max value of f. Yes, which happens at x equal to 3. But the value is negative 61. And this is the highest one, so this is, oh, sorry, I meant to write min. This is the highest one. This is absolute max value of f, which happens at x equal to 0. Let's do 2 more examples. Any questions? Any comments here? Critical points, end points. That's all you need to do for absolute max. Yes, please.
Is there any way to determine the
So f of 4 is not going to be neither local max nor it's not local. See, why it is not local? Because we know local max happens only in the critical points. 4 was not a critical point. Yes? So it's not going to be a critical local max or local mean. But this method is not dealing with local things. Yes? This is only for absolute. Local, we will need to do different story. Okay? Other question? Any other comments? I have 3 questions, 3 examples. I would like to include it here. The function is the third root of x, x plus 1 on the interval negative 1 and 1. The function is f of x equals to x plus sine x on the interval 0 to 2 pi. And one more. I should do it here.
tried my best at it.
One more. F of x is x minus 2 squared, 2x plus 1 to the power 3 on the interval 0, 2. I don't think I will have enough time to give you to work on these ones. How about let's do this? This example, you guys are working on this example, and you guys are working on this example. Where are we starting from? We are trying to find critical points. Throw away the critical points that are not in the given interval. The endpoints of the interval, evaluate and find the largest, smallest. Are we all good? Are we all good here? Then start. You guys are doing this example on the left. You guys are doing example on the right. Go ahead, please. And you have only 2 minutes, by the way. Are you doing the example on the left? It's a good, tricky example. Do it, please.
Okay, thanks.
One minute left. Are you done? Died? Okay. Do we have critical points for this guy here? How many critical points we have? 1, 2. Okay, let me see how many more. Do we have 2 critical points? What are the critical points you're saying?
X equal to 1/2 and x can't equal
0. X0, and then x equal to half. You did a differentiation here, yes? So you did f prime x. I can simplify this function and write x third root of x plus the third root of x, yes? And then use the power rule. This will give me 4/3 the third root of x. This one will give me 1/3
multiplied by
third root of x squared, yeah? Or, because, let me write this one so that, yeah. And then we try to evaluate this. So this here, then there is a 4 times third root of x over 3 plus 1/3 x squared that. Yeah? Well, more simplification is needed because I want to write it clearly here. Then this will give me 4 times x. Third root of x squared times the third root of x is third root of x cubed, which is x, plus 1. Yeah? And one thing that you should see it here, but you will be able to see it here as well, is that function is defined at 0. Yes? Because it's a good function. But when you expand this, the third root of x is one of those functions that has a vertical tangent line. So it's not differentiable at x equal to 3. So that means that's one of the critical points. And you can also see it here. When you did all the differentiation, this is making the denominator 0, so it cannot be 0. This is equal to 0 implies that x is negative 1 over 4. That's another critical point. Now we have to evaluate f at 0, which is 0. F at negative 1 over 4, I don't know what is that. We will figure out that one. F at negative 1 is 0. F at 1 is, this is 1, this is 2. So this is 2. Okay? What about f at negative 1 over 4? It is third root of negative 1 over 4, which I don't know what is it at the moment, times 3 over 4. Okay, do I need to find the exact value? Not really in this case. Because when I'm looking at these ones, these guys are giving me 0 or positive number. This is the only negative number I have. So this is absolute min value. And this is absolute max value. Oh, it is 20 now already. Let me quickly at least tell you what will happen here. If you do the differentiation with the product rule, then you can simplify and you can write it in this form. F prime is x minus 2, 2x plus 1 squared times 10x minus 10. Set it equal to 0. You get 2, you get negative half, you get 4. But this one, I don't want that one because it's not in the interval. F at 2 is 0. F at 4, sorry, I don't need 4 neither because this is not in the interval as well. F at 0 is 4. There are only two values. One is giving me absolute max, the other one is giving me absolute min. Have a great day. Come back tomorrow for the review session.